relationship between line and phase voltages and currents in delta connection. This is the delta connection shown here, where I RY, I YB and I BR are the phase currents, and IY, IR, IB are the line currents. So in generalized way, we can represent this with IL and this with I phase. Now, from the phasor diagram, you can observe that the line currents are 120 degrees apart from each other as well as phase currents. Now, from the diagram, currents in each line is the vector difference of two phase currents flowing through the line. Then we can write IR equals to IBR minus IRY, and IY equals to IRY minus IYB, and IB equals to IYB minus IBR. So vectorial difference, right? Now let us find out IR. IR square equals to IBR minus IRY whole square. Then IR equals to square root of IBR square plus IRY square minus 2 IBR minus IRY cos of the angle between these two. We will be getting 60 degrees, the angle between these two. So cos 60 degrees. Now generalize this, then you can write this as square root of IPH square plus I phase square plus minus of minus 2 I phase cos 60 is 1 by 2. To get cancelled, then you can write this as root of 3 IPH square, from which you can write root 3 times of I phase. If you generalize this, you can write this as IL equals to root 3 times of I phase. Then the voltages. Since the neutral does not exist in the delta connection, phase voltage is same as that of the line voltage. Then you can write V RY equals to V YB equals to V BR equals to line voltage VL in generalized term, which equals to the phase voltage. By generalizing, you can say that the line voltage is equals to the phase voltage in delta connection. Line currents are 30 degrees behind the respective phase currents. You can see from the figure. And the angle between the line currents and the corresponding line voltages, line current and the corresponding line voltage, this is VRY, is 30 plus 5. Similarly, and here. Now, power in delta connection. Now, the real power delta connection is given by P equals to 3 times of VPH IPH cos phi. That equals to 3 times VPH is equals to VL, whereas IPH equals to IL by root 3 cos pi. Then P equals to root 3 times of VL IL cos pi, which is in watts. Now reactive power Q is given by root 3 times of VL IL sin pi. This is in VAR. Then complex power or apparent power S is given by real power plus J reactive power Q. Then S is given by square root of P square plus Q square. If you find this, then you are going to get root 3 times VL IL. This is in volts amps. This is regarding the relationships between the line and phase voltages and currents, as well as the powers in delta connection. If this video is useful, please like, share and subscribe.